Hello and welcome to the second section of Chapter 2. We're going to talk about normal distributions today. So these are our objectives. We're going to talk about the 68, 95, 99.7 rule, standard normal distribution. We're going to talk about normal distribution calculations, and then we're going to talk about and finish with assessing normality. All right, so let's take a look at a normal distribution or a normal curve. So in a normal distribution or normal curve, the mean is located at the center. Of course, it's symmetric, and the mean and the median are the same. Secondly, the standard deviation, which is represented by the Greek letter sigma, defines the spread of the curve. Right, so you can see that the greater the standard deviation is with respect to the mean, the greater the spread for the distribution. All right, so let's talk about the 68, 95, 99.7 rule. So the 68, 95, 99.7 rule is basically talking about the percent of the area of the curve that's within a certain number of standard deviations. All right, so if I were to draw my normal curve, and each one of these numbers here lists the number of standard deviations to the right and then to the left of the mean. If I'm a standard deviation to the right of the mean, it's a positive value. To the left of the mean, it's a negative value. And so if I take the area under the curve, the standard normal curve, one standard deviation to the right and one standard deviation to the left, then I have 68% of that area. So we're going to say 68% of the data that's represented under this normal curve is between -1 and 1 standard deviations. Now extending that to 2, I'm going to say 95% of the observations or the data are going to fall within 2 standard deviations, or between -2 and +2 standard deviations. And then finally, 3 standard deviations takes up almost the entire area of the curve. So 99.7% of the area under the curve is represented within ±3 standard deviations from the mean. All right, so that's the 68, 95, 99.7 rule. And then I've given you the the Greek letter sigma for standard deviation, which you'll see in your textbook. All right, so let's take an example. The example test scores for the California test of basic skills have a mean of 6.84, if you can see this okay, and a standard deviation of 1.55. What percent of the population of the scores are less than 3.74? Right, so the first thing we're going to do is we're going to draw a picture of the standard normal curve to contextualize the question. Right. Then the second step is we're going to determine the number of standard deviations from the mean represented by 3.74. So we're going to take that data point, we're going to subtract the mean, and then we're going to divide it by the standard deviation. So data point minus mean divided by standard deviation is going to give us our z-score, which is basically the number of standard deviations from the mean. Okay, and so if we evaluate that, 3.74 minus 6.84 divided by 1.55 is -2 standard deviations, or my z-score is -2z. All right, so then I want to determine the area to the left of 3.74, right? Because we're asking for scores less than 3.74, which means I want to consider all of the area to the right of that. So if I go back to my 68, 95, 99.7 rule, then I know that if 2 standard deviations from the center to the left, so -2 standard deviations, will take up half of the right-hand side of the area of the normal distribution, and then another 47.5%, which is really half of the 95%, which would fall between 3.74 and 2 standard deviations. So I know that this area here is half of 95%, or 47.5. So I'm going to take 50%, which is all of the area, plus 47.5%, which is 97.5%, is represented by everything greater than 3.74. And now that we want to know what's less than 3.74, we just take 100%, or 1 minus 0.975, and we end up with 2.5% is less than 3.74. So we're going to say 2.5% of the scores are less than 3.74. All right. Okay, so this brings us to classwork 2.2.1. Here's an example of test scores for the California Test of Basic Skills. They have a mean of 6.84 and a standard deviation of 1.55. What percent of the scores are between 5.29, so this is 1 standard deviation, and 9.94, which is 2 standard deviations to the right. All right, so that's your first classwork problem. I'm going to pause here, or you can pause while you copy this down, and then I'm going to move on. Okay, so second topic we want to talk about is the standard normal distribution. So let's define what the standard normal distribution is. Standard normal distribution has a mean of 0 and a standard deviation of 1. So I'm basically superimposing these values onto some distribution in a way so that the mean is 0 and each standard deviation is equivalent to some integer value multiplied by 1. All right. So I have 1z, 2z, 3z, and then -1, -2, -3 as these values for the standard deviation. So that's a standard normal distribution. All right, so now we want to find the area to the left in a standard normal curve. And there is a standard normal table that's in the appendix in the back of your book. It's called Table A, and it's going to give you the z values. All right, and the Table A is going to provide you with the area underneath this curve, which is equal to 1. And basically we're dealing now with proportions and percentages. And the area is going to, Table A will provide you with the area to the left of this given z-score. All right, so if in this case my z-score is 0.81, which means I'm trying to find the number of data points within the standard normal curve, or percent, that is to the left of a z-score of 0.81. Then I'm going to go to my table in the back of the book, and I'm going to look up first digit here, and then second, so 0.81, and then I'm going to cross-reference this as 0.7910, which means that 0.7910, or 79.1% of the area underneath this curve, is represented to the left of a z-score of 0.81. Okay, so we're using this now because sometimes, and most of the time, we're not going to end up with characterizations where the z value is some specific integer, and mostly it's going to be some portion of that z-score value. So not 1, 2, 3, 0, -1, -2, -3. Okay, so we need to be able to find this using a table and then also using a calculator. And that table is in the back of your book. It's called Table A. All right, so this is finding the area to the left. And then if we want to find the area to the right, so in this case, remember, Table A is going to give us the area to the left. I want to find out what the area is to the right of a z-score of -1.78, which means I have to find the area to the left first, because that's what I get in the table. Using my table, -1.78 for the z-score gives me a value of 0.0375, which means 3.75% of the data is going to lie to the left of a z-score of -1.78, which means to the right is going to be 1 minus 0.0375, and that's equal to 0.9625 or 96.25% of the area of the curve, or the represented data, is going to fall to the right of a z-score of negative 1.78. So you can see that really as we move past the z-score of negative 1 and plus 1, then the values are going to be limited in terms of the proportion under the area of the curve, because more than half and almost 3/4, let's say 2/3 of the area is between negative 1 and 1. All right. So that's finding to the right. So we talked about to the left, to the right, and now we want to find in the middle of. Okay, so I have this area here, and I want to find out what this area is, what proportion of the distribution lies in this area. So I'm going to have to use two values. I want to find out what value is to the left of this value, and then what value is to the left of this value here. So this is a z-score of negative 1.25, and this is a z-score of 0.81. So I'm going to subtract this value from the area to the left of a z-score of 0.81, which is this entire value here, to get this band here between a z-score of 0.81 and a z-score of negative 1.25. So let's see how that works. Right, so if you go to your table and look at the values, a z-score of 0.81 will give you 0.7910. So I'm going to calculate this value, and then I'm going to subtract the area, the proportion of the area that's found with a z-score of negative 1.25, which is 0.0156. And so I end up with this black band here, or this red band, which is 0.81 minus negative 1.25, or 0.6854. So 68.54% of the area under this curve, or the distribution of some event, is represented in this band of the distribution. Okay, so that's how you find area in the middle of a standard normal curve. So we talked about to the left of, to the right of, and then in the middle. All right, so this brings us to our second classwork problem, 2.2.2. So you're going to use Table A in the back of the book to find the proportion of observations in a normal distribution that are more than 1.53 standard deviations above the mean. So you can write this down, and I'm going to move on a second. Please pause. Okay, I want to call your attention now to, in your book, there are some directions on drawing the standard normal curve and then to find areas based on certain z-scores. Okay, so I'm not going to go through this. I'll go through this at another point in time, but I wanted to call your attention to this information. Of course, you can copy this down, and I did give you a cheat sheet that goes over this information. Okay, this brings us to classwork 2.2.3, and I'm going to show this to you. All right, so I want you to use Table A again to find the z value from the standard normal distribution that satisfies the condition below of the 20th percentile. All right, so draw a picture, find that point, use the table, and you're going to pause here to calculate this. Now I'm going to move on. Okay, third discussion we want to have is normal distribution calculations. And so what we're going to do is we're going to apply what we talked about to real life situations, and we're going to translate it to that standard normal curve. And so we talked about this process here, state, plan, do, conclude. And so we're going to go through state, plan, do, conclude for our examples. So let's take a look at, and I'm not going to go through this, you can copy this down, but I'm going to give you these examples, and I'm going to follow this process, state, plan, do, conclude, for the answers. All right, so the question is, when Tiger Woods hits a golf ball, the mean distance it travels is 304 yards. Each hit has a standard deviation of 8 yards. What percent of Tiger's drives travel at least 290 yards? All right, I'm going to pause here. We're going to come back to this question. as we move on in the next part of this video.